Hi everybody, and in this video I just want to take you through some basic evaluation of logarithmic expressions. And so we'll just work through them together. We'll give you just a mishmash of questions here. And so the first one that I would ask, just a very simple question, would be something like express 4 to the power of 2 equals 16 in logarithmic form. Okay, so if I saw this, what I would say is, well, the base of the exponent becomes the base of my logarithm. The answer to a logarithmic question is going to be equal to the exponent power that I'm looking for. Okay, because remember, that's one of the purposes of why we use logarithms, is to basically say to ourselves, I want to get an answer to a problem where I have an exponent. Sometimes it's a variable, and I need the output of my function to be that answer. And the original answer to my exponential question becomes the argument of my logarithm. And remember, if you didn't see this 2 on the right-hand side there, what this logarithm here would be saying is 4 raised to what power equals 16? And the answer to that question is, of course, 2. So the expression 4 to the power of 2 equals 16, written in logarithmic form, would be log base 4 argument 16 equals 2. Okay, let's do another one here. Let's do log base 2 8 equals 3. So let's say we have the expression log base 2 8 equals 3, write it in exponential form. Well, this goes back to our kind of, logarithmic and exponential identity, which was that if we had log base a x equals y, we could rewrite that as a to the y equals x. And that's something that I would strongly encourage you to kind of ingrain in your memory, because that kind of describes the relationship that exists in terms of the equivalence between logarithms and exponentials. So all I need to do for this problem is I just need to apply that kind of template and say 2 to the 3 equals 8. And I've done that question there. Let's do another one here. Let's say I have a simple question such as evaluate log base 5. Evaluate. So what I'm asking myself is 5 raised to what power equals 5? 5 raised to what power equals 5? We can say, well, we'll raise it to some power. We can even call it x if we want, or we can call it y. It doesn't matter. But 5 raised to what power equals 5? Well, the answer is 5 raised to the first power is equal to 5. Okay? 5 to the power of 1 is equal to 5. Now, another way you could look at that, if you found that confusing, is that you could apply that formula we talked about, which is called the change of base formula. And you could say, well, this is really equivalent to the log base 10 of 5 over the log base 10 of 5. And of course, anything divided by itself is equal to 1. So that would give you the answer as well. And that would be totally fine if you wanted to do it that way, okay? And another way I suppose you could do it, if you really wanted to, is you could look at this and you could say, well, this is like saying 5 to the x equals 5 to the 1. And then you could say, well, the bases are the same, so I'll just go ahead and write it as x equals 1. And then finally, let me show you one other thing you could do if you really wanted to. You could look at that original expression, log base 5 argument 5 equals x, and you could say, well, once again, that's like saying 5 to the power of x equals 5. And then what I could do is I could say, well, I'll just apply the logarithm rules that I've learned so far that we will talk about, and I'll take the log of both sides. And then what I will do is I will bring the x in front, because we talked about, or we've at least discussed, the power rule of logarithms, which we will continue to discuss in a future video. And And then what I could do is I could divide by log 5, divide by log 5, and I have x equals, that's a 5, sorry, x equals 1. Okay, so that's another way that you could potentially tackle that problem. There's lots of ways. Let's go back and now let's think of another question we might see. Well, how about if we saw something like this, log base 7 root 7. Evaluate log base 7 root 7. So what you could just look at this and say, well, this means 7 raised to what power equals square root of 7? And the answer is 1/2, because 7 to the power of 1/2 is equal to the square root of 7. Remember that x to the power of 1/2 is equivalent to the square root of x. Those are equivalent statements. So what else? Well, we can go down our list of questions to do. And I think, another one, a typical question you get is something like this. Evaluate. So what did I say? Evaluate. So we'll say eval. Log base 3, 81 plus, okay, log base 4, 64. All right, so we look at that and we say, how can we rewrite this? Well, what we can say is 3 to the power of what equals 81? Well, 3 to the power of 3 equals 81, right? Well, actually, my fault. 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, 3 to the power of 4 is 81. So log base 3 argument 81 is 4, plus 4 to the power of 3 equals 64. And so our answer to this question is 7. So that's another type of question you can do if you understand the laws of logarithms. Look at this one. Use your knowledge of logarithms to solve the following equation. Okay, log base 5. So we're going to solve log base 5x equals 3. And solve for x. Well, 5 to the power of 3 equals x. X equals 125. Okay, once we know the relationship that exists between logarithms and exponents, it really opens up a lot of potential questions for us to do. How about this one? Log base 27x equals 3. Log base 27x equals 3. Okay. Log base 27, or did I say, no, I meant to say log base x 27 equals 3, sorry. Log base x 27 equals 3. So x to the power of 3 equals 27. Okay, now we're trying to solve this, right? Now this question here, we're trying to solve for x. So what we'll do with this question is we'll realize that the thing we're trying to solve for is not an exponent, it's a base. So I can take the cubed root of the left-hand side and the cubed root of the right-hand side. The cubed root of a cube cancels out, and I'm left with the cubed root of 27. That's a 3, sorry. And of course, the cubed root of 27 can be done on your calculator. That's just 27 to the power of 1/3, which is equal to 3. So that's another example of a logarithm evaluation question that we could do. Let's do a couple more. Here's a question that might give you some interest. What if I said, use the graph to estimate each of the following. Use a graph to estimate each of the following. So in other words, I imagine I had a function that was this, log base 3, 17, right? And it's saying use a graph to estimate what the answer to that would be. Well, what we would do in a situation like that is we would picture the graph of log base 3, x. Right? In other words, we would be, what would the graph of y equals log base 3x be? Well, it would be something like this. It would be a graph that looks like something like that, okay? And so if I said, I plugged in 17 for x, So I said y equals log base 3, 17. All I would do is I would follow my graph over to where x is equal to 17, somewhere here. I don't know where that is, but just estimating. And then I would follow it back to what the y value was. Now, what is that y value? Well, I could draw the graph on Desmos and figure out what the y value is just by going along the graph until I hit x equals 17, then going up to the graph, so going along the x-axis until I reach 17, going up to the graph and then seeing what the output is. But of course, I could also just interpret the question as 3 raised to some power y equals 17. What is that power y that I'm raising it to? Well, to figure that out, what I could do is I could say to myself, I think I'll just evaluate this and say that without even using any algebra at all, I'll just use the change of base formula and say y equals the log base 10 of 17 over the log base 10 of 3. And then taking out my calculator, I will say log 17 divided by log 3 is equal to 2.57. So the answer approximately to the question evaluate log base 3 argument 17 is 2.57. So that's kind of interesting. And now let's do one more together here. Let's go ahead and do a tricky one here. What would be 5 to the power of log base 525? What would be evaluate the expression. Here we go. So evaluate the expression 5 to the power of log base 5 argument 25. In other words, what does that equal? Well, to figure out what that equals, we should first of all evaluate that. What is log base 5 25? Well, what would I have to raise 5 by to get 25? And the answer is that's equal to 2. So my real question now becomes 5 squared, which is 25. And that would be the answer to that question, 25. And that brings us to a really interesting final conclusion, which is that if I have the expression a to the power of log base ab, if I have the expression a to the power of log base ab, the answer will just be b, as we just showed there, right? The b was our final answer. So it's just kind of an interesting conclusion to end off our video with. Thanks for watching, and that's some work there we did with evaluating logarithms.